Yes, welcome back. Welcome back to EDUHUNT IIT and NEET Foundation program. This is Sukumar, your chemistry mentor. Yes, we just completed types of chemical reactions. Okay, with the previous video, we completed types of chemical reactions. Now, in this video, I am going to explain one more important classification of reactions, chemical reactions. That means, chemical reactions can be classified into two types on the basis of energy changes or simply on the basis of heat changes. Okay, let me write. On the basis of heat changes. On the basis of heat changes. On the basis of heat changes, chemical reactions can be classified into two types. Simple. It's very simple classification. On the basis of heat changes, the chemical reactions can be classified into two types. Sir, what are they, sir? Yes, there are two types. One is exothermic reactions. And the another one is endothermic reactions. Endothermic reactions. Simply two times on the basis of the heat changes. Sir, what is this exothermic reaction and what is this endothermic reaction? Simply, see, whenever a chemical reaction takes place, there are two possibilities generally. Heat can be released, heat can be absorbed. In general, these are the two possibilities. Whenever any chemical reaction, natural reaction, artificial reaction, laboratory reaction, the chemical reaction happening in our body or in the lab, any chemical reaction. If any chemical reaction takes place, there are two possibilities. Heat can be released or heat can be absorbed. If in a chemical reaction heat releases, then that is called exothermic reaction. In this heat released during reaction. Simple. That means while or when that reaction is happening, during the course of reaction, heat releases. Okay, so that is exothermic reaction. So when that reaction happens, heat releases. Similarly, opposite to that, when a reaction takes place and heat is absorbed in that reaction, then that is endothermic reaction. Heat absorbed during reaction. Okay, so one thing you can notice here, for this reaction to happen or for this reaction, I'm pointing towards exothermic reaction. For this reaction to take place, there must be conditions or there must be something, proper arrangement or possibility for the heat to be released. Imagine if there is any obstruction we created. Imagine if there is any obstruction we created for the flow of heat, then there is no chance for heat release. When there is no chance for heat release, then there is no chance for that reaction to take place, because exothermic reaction only possible when there is a chance for heat release. So obviously when heat releases, exothermic reaction takes place, or when simply it is better to say like this: during the course of exothermic reaction, along with the reaction, during the reaction, heat releases. Similarly, endothermic reaction takes place by the absorption of heat. Okay, more is the supply of heat, more is the chances for this reaction to take place. So in this reaction, you have to supply energy, you have to supply heat, then the reaction takes place. But this reaction takes place by releasing energy, you have to take that energy. So when there is a exothermic reaction takes place in front of you, that reaction takes place and energy comes out, you have to take, we feel that heat sensation, right? Yes. Now getting into the details one by one, but let me give you a hint regarding, sir, we know very well the basic fundamental thermodynamic law, that is, energy can neither be created nor destroyed. Energy can neither be created nor destroyed, but can be transformed from one form to another form. Now think about this carefully. In exothermic reaction, heat releases means the released heat is not created. The energy already existing in the chemicals is somehow releasing outside, right? Yes. Now I am going to explain that in terms of exothermic reaction. Let me take next page. Yes. For suppose, let's consider A plus B as reactants. A plus B as reactants gives rise to C plus D products. Okay. Now if I say this reaction is exothermic, if it is exothermic, then this reaction during the process, it has to release energy. It has to release energy. Okay, but that energy is not newly created. That energy is not newly created. Energy can neither be created nor destroyed. Okay, so only the energy present inside the chemicals is somehow releasing outside, right? Yes. Now tell me, the A and B are chemicals, they are reactants, they are chemicals, and C and D are different chemicals. Different, that's why different products. The point is, in chemicals there are energy called chemical energy. How, sir? How a chemical have energy, sir? You know bonds, bond energy? Yes. For suppose this is carbon dioxide molecule, there is a bond between carbon and oxygen, double bond. If it is an NaCl, sodium chlorine ionic bond, bonds have bond energy. Right? Similarly, atoms, inside atom, there is energy levels. You studied in atomic structure chapter. So the point is, these reactant chemicals has some chemical energy inside it. Some chemical. Similarly, the products have some chemical energy inside the molecules or atoms, but the energies are different, because different chemicals, different energies. Different chemicals, different energies. Now let me take, if energy of the reactants, I am taking energy of the reactants. ER means, what I mean by ER is energy of the reactants. If energy of the reactants greater than energy of the products, okay? How, sir? Let's assume some normal dummy value, okay? If energy of the reactants is 100, energy of the reactants is 100, okay, and energy of the products is somehow less than that, because I have taken as an assumption if energy of the reactants greater than energy of the products. So take the energy of the products somewhat less than 100. I am taking 80. Okay. Now, reactants with 100 units of energy, you can take any unit of energy, calorie, joule. For example purpose, I have taken this, na? Yes. The reactants with 100 units of energy now converted into products with only 80 units of energy. Again, the reactants with 100 units of energy. Okay, see, don't take these values seriously, but understand what happening seriously. See, these are the reactants with total 100 units of energy. Reactants with 100 units of energy converted to products with just 80 units of energy. Now, where that 20 units of energy gone? Is it vanished? Is that 20 units of energy destroyed? No. We know very well that energy can't be destroyed. Yes, that missing 20 units of energy is released in the form of heat. That missing 20 units of energy is released in the form of heat. Okay, sir. Okay, fine, sir. Then how to show that on paper, sir? How to show that on equation, sir? Yes. I am going to write that heat also along with the products. How, sir? Why, sir? Yes. See, in a reaction, products releases. In a reaction, products are released. And in a reaction, heat is also released. That's why I am in one way, I am imagining heat also as a product. Right? Yes, that's why along with the products, I am writing heat. What's wrong in that? Yes. Now, you tell me, these two reactants, these two products together have how much energy? These two products together have how much energy? 80. And what is the amount of heat released? Yes, that missing 20 plus 20. So, these 20 units. The point is, initially the total reactants have 100 units of energy. Now, that 100 units of energy distributed into two forms, 80 units of energy inside products, and the rest of the 20 units of energy released in the form of heat, energy conserved. So now it is justified. Energy can neither be created nor destroyed, but can be transformed from one form to another form. In this case, that is the heat form. Now this is exothermic reaction. Now let me explain in the same way what is endothermic reaction. Okay, but let me tell you, in the further classes there are three more ways to express this. Okay, this is not only the way, you can express exothermic reaction in other ways also. Okay, fine. Now, okay, now what is endothermic reaction? Endothermic reaction. Now let me take a different example. X plus Y gives rise to C plus alpha plus beta. Okay, X plus Y gives rise to alpha plus beta. What I mean by here is X plus Y are reactants and alpha and beta are products. Okay, sir, fine, sir. Now, I am assuming here energy of the products is greater than energy of the reactants. This is possible, na? Yes. Sir, how, sir? How much, sir? Let's take an example purpose. Reverse the values. Okay. Let us say together these reactants has 70 units of energy. Reactants has 70 units of energy. Reactants are separate individual chemicals. They have their own structure. They have their own bonding. They have their own energies. Yes, these two reactants together have 70 units of energy. Fine, sir. and reaction happen, products are formed. And if you check properly, these products have somewhat more energy because I have assumed energy of the products greater than energy of the reactants. That is the case we have taken. Okay, imagine products have 100 units of energy. Is that quite possible, na? Yes, possible, sir. These are different chemicals. These are different chemicals. Different chemicals have different geometries, different stabilities, different energies. Yes, fine. But law of conservation of energy says energy can neither be created nor destroyed, right? Now how 70 units of energy converted to 100 units of energy, right? See, from the reactants with 70 units of energy to get the products with 100 units of energy, 30 units of energy has to be created, na? No, that is not possible. Energy can neither be created nor destroyed. Now what happened? Yes, you have to supply that 30 units of heat, 30 units of energy, otherwise this reaction won't happen. Okay, so you might have supplied it knowingly, unknowingly. See, if this reaction happened in nature, what happens? This reaction might have absorbed energy from the atmosphere. And if you want to conduct this reaction in a laboratory, you have to supply energy, otherwise this reaction won't happen. Yes. So, X plus Y plus some amount of energy. Or I can read. So, let me erase this for better placement. Yes. X plus Y. These two together have 70 units of energy. Now I am supplying some heat to it so that the reaction will happen. How much heat, sir? Yes, energy can neither be created nor destroyed. 70 plus 30 units of heat we supplied, together we got 100 units of the products with 100 units of energy. And again energy can neither be created nor destroyed. Only energy from one form to other form. Energy can be converted from one form to other form. Here from heat form to chemical energy form. Okay, the energy present in the chemical simply called as chemical energy. Okay, now from the chemicals it is absorbed, it is released as heat energy. Okay, so these are the two ways of understanding chemical reactions in terms of heat, exothermic and endothermic. In the next video, I am going to explain what are the types of, what are the examples, best examples of exothermic reaction and endothermic reaction. Stay tuned. Thank you.